A very happy morning to all of you. So today we are going to talk about Unit 1, wherein we will be talking about physical properties and chemical constituents. And in this we are going to start with Parachor. Okay, but prior we start discussing about Parachor, let us talk about what is meant by physical properties and chemical constituents. Physical properties. Physical properties refers to the characteristics of a substance which can be observed, measured without doing any change in chemical composition. अगर कोई भी substance की कैरेक्टरिस्टिक्स जिनको मेजर किया जा सकता है, ऑब्जर्व किया जा सकता है बिना उनकी केमिकल कॉम्पोजिशन में चेंज किए, उसे हम फिजिकल प्रॉपर्टीज कहते हैं. फॉर एग्जाम्पल इट कैन बी कलर, अडर, मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, डेंसिटी, सरफेस टेंशन, विस्कोसिटी, solubility, refractive index, etc. These all physical properties of the substance depend on the intermolecular forces, right? So if we determine any of these physical property, say for example if we measure surface tension, viscosity, refractive index, etc., we can give valuable information about the structure of the molecule since these depend upon intermolecular forces. These physical properties can be classified into two classes, additive properties and constitutive property. पहले हम बात करते हैं additive properties के बारे में. The physical property of a substance which is equal to the sum of the corresponding properties of its constituent atoms is known as additive property. Means वो प्रॉपर्टी किसी भी सब्सटेंस की जो उसके कॉन्स्टिट्यूएंट एटम की प्रॉपर्टीज के सम के बराबर होती है उसे एडिटिव प्रॉपर्टी कहते हैं. फॉर एग्जाम्पल मॉलिक्यूलर मास, किसी भी मॉलिक्यूल का मॉलिक्यूलर मास उसके इंडिविजुअल एटम के एटॉमिक मास के सम के बराबर होता है. मॉलिक्यूलर मास इज अ फिजिकल additive property. Similarly, thermal conductivity is also an additive property since it can be obtained by adding together the thermal conductivities of its individual components. Now let us talk about constitutive properties. The property which depend upon arrangement of atoms and bond structures in a molecule are termed as constitutive properties. वो सारी फिजिकल प्रॉपर्टीज जो किसी भी मॉलिक्यूल के इंटरमॉलिक्यूलर फोर्सेस में उसमें अरेंजमेंट ऑफ एटम्स पे किस तरह के उसमें बॉन्ड हैं उन पे डिपेंड करती हैं, वे फिजिकल प्रॉपर्टीज कॉन्स्टिट्यूटिव प्रॉपर्टीज कहलाती हैं. All these properties can't be broken down into simpler components, means these can't be said to be sum of individual components. These properties describe the fundamental behavior of a substance, like how the substance would respond to external forces or any stimuli such as stress, strain, heat or electromagnetic field. Example of constitutive properties include surface tension, viscosity, Young's modulus, optical activity, and coefficient of thermal expansion. Now let us speak about what is the meaning of the term Parachor. I believe you must be hearing this term for the first time. Yes? Okay. So the term Parachor has come from two Greek words. Para. Para means aside and core means space, right? It is actually a constant, an empirical constant for the liquid, and it is used to relate surface tension of a liquid to the molecular volume. It depends upon molecular size and shape of the substance, and it is related to intermolecular forces. In that manner, it is a constitutive property. The term Parachor was first given by Suzanne and MacLeod in 1923 studied a large number of liquids, and after studying a large number of liquid he related surface tension and density of liquid and vapor by the equation as shown over here. Gamma to the power 1 by 4 upon capital D minus small d is always a constant, where gamma is surface tension, capital D is the density of liquid and small d is the density of vapor at the same temperature. C here is constant. In 1924, Sussden modified this equation and multiplied both left-hand side and right-hand side with the molecular mass. And the modified equation is m gamma to the power 1 by 4 upon capital D minus small d equals to m into C. Here m into C, that is molecular mass into the constant, is redefined as the term Parachor. So the quantity Parachor is actually constant for a liquid because C is constant and molecular mass for a given liquid is always a constant. Small d, that is density of vapor, is negligible as compared to capital D. So we can rewrite equation number 2 in this manner. Capital M into gamma to the power 1 by 4 upon capital D is equal to Parachor. Small d being negligible, we have just omitted it. Now, molecular mass upon density is nothing but the molar volume. So, we can rewrite it as molar volume into gamma to the power 1 by 4 is equals to Parachor, where Vm is the molar volume of the liquid. If gamma is unity, then what we can say is molar volume is equal to Parachor. So, from this we can define Parachor as the molar volume of a liquid at any temperature when its surface tension is unity. Right? Parachor is defined as molar volume of a liquid at a temperature when surface tension is unity. Now, what is the need of studying Parachor? Why do we study Parachor? What is the use of Parachor? It is very important, as we have already seen that it depends upon intermolecular forces, it depends upon the structure and shape of the molecule. So, studying Parachor, we can understand the behavior of a substance in various physical and chemical processes. We can infer about the solubility nature, about its vapor pressure, about boiling point, etc. All those substances which have similar Parachor values, all the liquids which have similar Parachor value will definitely be having similar kind of intermolecular forces, and therefore their behavior would be similar. For example, the substance with higher Parachor value will have higher boiling point and lower vapor pressure, indicate that they have strong intermolecular forces. Parachor is also used to predict the mixing of liquids. All those substances which have similar Parachor values, they will be miscible into each other. That is, they will be soluble into each other. And the concept of the Parachor of mixing can be used to predict the behavior of mixture of substances with different Parachor values, such as solubility of one substance in another. Okay, now let us check how Parachor is used in determining the chemical constitution of any compound. These are few bullet points which have been summarized on this slide, which will infer about the role of Parachor in determining the chemical constitution of the compound. First of all, Parachor is used to predict the molecular structure and behavior based on surface tension. It also provides insight into different atoms and functional groups, which contribute to the overall surface tension of the compound. This reveals that Parachor is an additive property. So Parachor is both an additive as well as constitutive property. Second, about intermolecular forces. Parachor help us to understand the nature and strength of intermolecular forces of a compound. And if we compare the Parachor value of two different compounds, we may infer about the type of intermolecular forces like whether van der Waals forces, hydrogen bonding, dipole-dipole interaction, etc. Parachor is also used to assess the solubility and miscibility of the compound in various solvents. Although substances which have similar Parachor value are more likely to be miscible into each other due to similar intermolecular forces. Besides, Parachor is used in group contribution method, where the contribution of each functional group to the overall Parachor is considered. This approach simplifies the estimation of Parachor for complex molecules by breaking them down into smaller functional groups. Parachor is helpful in establishing structure property relationship between uh, compounds. It allows scientists to design compounds with specific properties by manipulating their chemical constitution. Now, let us talk about the experimental studies done related to Parachor. Sussman examined the experimental Parachor value of a number of organic compounds whose molecular structure was known, and he only revealed that Parachor is both an additive property as well as constitutive property. I believe all of us know about the difference between additive and constitutive properties. Yes, additive properties are those properties which are obtained by summing the property of constituent atoms, while constitutive property depend upon the structure of the molecule. So, Parachor is both additive and constitutive property. The Parachor of a compound can be expressed as a sum of atomic Parachor and structural Parachor. Atomic Parachor is the contribution of each of the atom present in the molecule, and structural Parachor is the contribution of the various bonds or rings present in the molecule. So in 1924, Sussman correlated experimental value of Parachor with the molecular structure, and he calculated atomic and structural Parachor as shown in table 1.1. But these values were further revised by more accurate measurement of surface tension by Vogel in 1948. So in the table, we are given the values of Sussman as well as Vogel for atomic Parachor and structural Parachor. Here you can see for carbon, hydrogen, nitrogen, oxygen, chlorine. Atomic Parachor values are given. In the second column, the values given by Sussman, and the third column, values given by Vogel is there. While structural Parachor, whether the structure consists bond or ring, single bond or double bond or coordinate bond, 3-membered ring is there or 6-membered ring is there, the values given by Sussman and Vogel are given. Here we have shown some of the examples wherein structure can be elucidated using Parachor values. Say for example, here the calculate structure of benzene is given, and using Vogel's data, the value of Parachor of calculate formula is determined to be 206.9, and its experimental value is also found to be 206.2. It actually support the calculate structure of benzene, right? 6 carbon, 6 into 8.6. 8.6 is the Parachor value given by Vogel. 6 hydrogen, 15.3 is the Vogel value, Parachor value of hydrogen, atomic Parachor. And 3 double bonds are there. So double bond, the constitutive Parachor value 19.9 is there. 6-membered ring, 1 ring is there, so 1.4. So summing it up, it comes out to be 206.9. This is the calculated value, and 206.2 is the experimental value. Since both the values are in close agreement with each other, the calculated structure is supported by Parachor calculated values. In the same manner, क्विनोन के लिए दो स्ट्रक्चर ए एंड स्ट्रक्चर बी प्रपोज किए गए थे, लेकिन द कैलकुलेटेड पैराकोर वैल्यू ऑफ स्ट्रक्चर ए इज इन एग्रीमेंट विद द एक्सपेरिमेंटल वैल्यू. स्ट्रक्चर ए की जो कैलकुलेटेड पैराकोर वैल्यू है वो 236.1 है, and experimental paracore value 236.8 है. Since both these values are in close agreement with each other, जबकि स्ट्रक्चर बी की कैलकुलेटेड वैल्यू 219 है. तो स्ट्रक्चर ए को हम एक्सेप्ट करते हैं और स्ट्रक्चर बी को हम डिस्कार्ड करते हैं फॉर फिनॉल. So paracore value can be used for structure elucidation as it is clear from these two examples. So this is all about paracore, and now this is the testing time. You need to answer these questions and send it to me. You need to define paracore. What is paracore? You need to discuss and explain the role of paracore in determining the chemical constitution of the compound. शॉर्ट नोट लिखिए पैराकोर पे. आपको पैराकोर इक्विवेलेंट फॉर कार्बन, हाइड्रोजन, ऑक्सीजन, ऑल दीज वैल्यूज आर गिवन एंड यू नीड टू कैलकुलेट द पैराकोर फॉर मिथेनॉल. Paracore equivalent of carbon, hydrogen and oxygen are given and you need to calculate the paracore of ethanol. Fill in the blank. So I hope I'll be getting these questions done by all of you. With this, I just wind up. Thank you so much. We'll meet in the next class for viscosity. Bye-bye.